Okay, my name is Raul Lopez. I'm going to give a talk that presents a perspective that's a little bit different from what we heard this morning on the case for Mars. And that's why basically the conclusion is different, but I think it's good to have debate, so I hope you bear with me. I'm an ophthalmologist. I practice in Puerto Rico. I'm also a space enthusiast. I don't work in the industry, but I've been interested in space exploration since the 1970s. I even had a website at one time where I promoted Mars colonization, and I dabbled in politics and also have a degree in theology, like to read about economics. My premise is that there is an urgent need to colonize space. So I'm going to talk a little bit about the urgency and look at it more from the perspective of actually colonizing space. I'm going to talk a little bit about that. I believe that we are facing problems here on Earth which are rapidly worsening and which can only be solved by space colonization. I think if you look at some trends, and I'm going to talk a little bit about some of those, that we are, there is a possibility that we could be really going into a period of stagnation. And I think we have to consider that as a possibility. And I think that space colonization, not just space exploration, but actually getting onto the establishing viable settlements would do something to really send us in a different direction. So I'm going to talk a little bit about the urgency, looking at some things that are going on here on Earth, because that determines in part what our goals should be. As a doctor, you look at how bad the disease is to determine whether the patient needs medication or he needs surgery. And again, what I'm going to be talking about is space colonization, not just manned missions. And space colonization means expanding civilization, having families, quasi-sufficient communities, farms, factories, and spending your life there. So it's not just the idea of exploration, establishing scientific bases. Okay. So why colonize space? Well, we have some problems that we're first facing here on Earth. They include diminishing freedom, limited resources, and I think you can see that there has been a lack of growth or progress. So we're basically would go to space to try to solve these problems, to preserve freedom, find new resources, and stimulate progress. And basically, colonizing space makes sense if only, or primarily, if we believe in the growth imperative. I'm not talking about sending, having missions for scientific purposes, but actually colonizing space is an outgrowth of what I call the growth imperative. And what is that? It's basically the idea, which is one of the foundations of Western civilization, that humanity experiences progress when we are productive, when we increase the population, when we fill all the land, and we basically subdue them and basically have dominion over nature. That's recorded all the way since the time of Moses. Countries and groups that follow this imperative prosper because they attract the best and the brightest, and they grow. However, we are probably the first generation which will not necessarily meet this goal. Now, it's hard to estimate the ultimate carrying capacity of the Earth, and technology will continue to increase, and this will probably increase. But we're probably less than one populational doubling away from our ability to grow enough food to feed the world cheaply with current technology. And there's other resources that I'm going to look at quickly that are scarce. And the reason I want to look at these is because, again, it gives us an idea of the urgency that we have. Now, what I call the space imperative is basically an outgrowth of that. It's a syllogism. If human progress needs a growing population, and Earth can no longer sustain a growing population, then if we want progress, we must basically go and find new land masses, new areas in which to expand, and the solar system fits that requirement. So if we accept those two first premises, then we must logically accept the conclusion. So some of the problems. We need to preserve freedom. Freedom is a bedrock of civilization. Free exchange of ideas and resources is necessary for innovation and growth. We see that in our culture in many different ways, from our politics, our history, our religion. History shows that an advanced civilization can only be maintained when people are free. Something kind of interesting, I've always wondered, why did the Roman Empire never create a steam engine? They had these little toys, basically, that were fueled by steam. So it's not that they didn't know about it, but they never went a small further step to this type of steam engine that actually did some useful work and began the Industrial Revolution. These were used as pumps in mines to pump out water. And I've heard some analysis on that, and basically they were saying they had too many slaves, too many taxes, and too many regulations. So instead, what they experienced was a progressive loss of freedom, and that was basically one of the essential roots of the collapse of the Roman Empire and of the Dark Ages which followed. Freedom of speech and association are essential. We have Patrick Henry, joining together with other people to plan the independence of the United States. Have this idea that truth shall make you free. But I've noticed in the last, say, 10, 20 years that there's an attack on freedom of speech and freedom of associations in many different ways. For example, here we have the Berkeley riots, and the thing is, we might not agree with the person who's speaking, but that doesn't mean that we have to start burning things and beating people up just because we disagree with them. The terrorist attack are fundamentally a war against having an open dialogue. We see the incredible amount of surveillance that is now happening with cameras everywhere. Our emails are being analyzed, and they're basically tracking where we go and what we say. And we need to do some of that for safety, but how far is this going to go? This is going to continue to worsen, and I believe that that'll put at risk some fundamental freedoms that we need to have a prosperous society. Now, in space, one of the advantages is that if you have a colony on Mars, the government here is not going to, governments on Earth are not going to be able to control it. It's going to be a lot more freedom. It's difficult to hack a computer on Mars when you have to wait 45 minutes for a response. You can't send invading forces to another planet from Earth because it'd be too expensive. And not just distance, but also when it comes to cost. We need to find new resources. Now, when I was young, I read the Limits to Growth, and I really did not agree with it. And I very optimistic and believe that we're always going to be, we're always going to solve these problems. But lately, we have really entered a period of quite a bit of stagnation. We see that here, that the GDP per capita has pretty much stagnated. It was growing quite fast, but we've reached kind of a point here of stagnation, and we don't know what's going to happen in the future. It might continue to go up. But I think that we are actually starting to run out of some key resources, energy sources, land. You can see that in examples like rare earth oxides. And the thing is that even though these are still increasing a little bit, but so is the population, so that the amount of resources per GDP is going down, and we see then that the per capita GDP is stalling. It's interesting when we look, and the thing is I started doing this research, and I actually became quite surprised. You see there's kind of exponential growth of oil. This was basically during the 50s up to about the 70s. And then it suddenly kind of reached a peak, or this is the growth of all forms of energy. It reached a peak, and then it's been growing rather slowly. And when it comes to oil production, it went up, kind of peaked, and then it's sort of been stagnant. And when we hit this inflection point, we got the oil crisis, the Iranian Revolution, and now basically even though the total energy and even the total oil production, if you look at, if you include like the tar sands, is still growing, but the amount of oil and energy per person is basically static. So the question is, what will happen when this actually now starts to go down? when this is no longer static and actually starts to go down, we hit a different inflection point. When will that happen, and what will happen at that point? The GDP is closely tied to energy output. It's very linear. It's amazing. This is total energy. And when it comes to oil, it became steepened in the 70s. So there's even a greater correlation. It's steepened after the energy crisis. What happened is that now we use oil for things where it is more essential, like in transportation. But what this means is that whatever oil we're using now, we're even more dependent on that for the GDP. It's interesting that we see an effect of that even in society. This is what's called the Gini. This is a measure of how equally spread out the resources, our wealth is in a society. We have Western Europe and the United States. It became, and as you go down it's better, so it became a lot more equal in the 50s. So the 50s you had a much larger middle class, probably the peak of the middle class, and since then it has started to decrease. So that means that a lot of that growth is being concentrated in the upper classes. The middle and lower class is actually getting poorer. And that was a period where we had the fastest growth in the production of oil. So that increase in resources, increase in energy is very important to have basically a stable society. And what we're seeing now is we're seeing a diminishing of the middle class, and perhaps that has contributed to some of the social instability, because middle class nations are probably more peaceful than those that are not. When we look at land, this is the amount of land that is used for agriculture. It hit a peak in the mid-90s and then has been declining slightly. Now, it's interesting that the global food supply per capita is still increasing, so we're getting a lot more yield out of that same amount of land. But there's a catch, because how are we doing that? We're doing that using energy. This is the energy used for agriculture, and we see how closely tied the price of oil and the price of energy, price of food is. I saw several people say that modern agriculture is a way to use land to turn oil into food. And it's interesting. Every calorie of food of plant food, plant-derived food that is produced, consumes 1 calorie of some kind of other energy source. For meat, it's actually 35 calories of energy for every calorie of meat. So what happens after the end of cheap oil? We use energy in fertilizer, pesticide, equipment operation, equipment manufacture, transportation, processing. So what happens when we run out of cheap oil? We see other resources that are being depleted. These are the rare earths. It's also reached kind of a peak here in the early around 2006. These metals are used in high strength magnets, motors, phosphors. Just an example that it seems that in a number of areas we're actually reaching a point of stagnation. And we need space exploration also to stimulate progress. These epic causes have disappeared. You look in among the people that are here at this meeting, and I'm surprised by the fact that except for some of these schools, there really are not too many young people that come to these meetings, even people, let's say, under the age of 30. When I grew up in Colorado, and I also grew up in Puerto Rico, and I knew people whose parents had been homesteaders. They probably came in, maybe not in covered wagons, but they came very, in early forms of transportation, perhaps by train. A lot of my friends, their parents had packed up and headed west from the states in the east. And when I lived in Puerto Rico, it was considered an economic miracle. It was growing at 10%. I live very close to a place where Columbus actually landed in Puerto Rico, and my ancestors are a mix of all these people that came, the Spanish, French colonists, the Indians, and the Africans, to produce a new civilization. There's nothing like that right now for our children, except, I believe, space exploration. And the millennials are are turning out to be the first generation in many years that are poorer than their parents. They call them the boomerang generation because they're going off to college and coming back to live with their parents. What happened to fusion energy and cure for cancer? When I was a child, there was a magazine called Fusion Magazine. I used to read it, and you know, every fusion was always 10 years away. Well, with this energy crisis looming, you'd think that they would put a lot more money into fusion energy. But fusion energy would be a great stimulus for space exploration. If we could have fusion-powered rockets and fusion generators, you know, on Mars and the planet and the other bodies of the solar system, that would be a great advantage. So I think that we are, you know, we are heading towards a difficult period. You know, we don't know how bad things are get, but we have, you know, we have to act now to pick what kind of future we want. Obviously, we'll never have utopia, and we'll probably never have dystopia. But which direction do we want our future to go? I always wondered, what if Rome had discovered America? You know, what if they had sent a ship and gone over to the Americas? Would there even have been a Dark Ages? Where would we be now in terms of civilization if somebody had just gone on a ship or even gotten lost on a ship, made it to America, and had come back to Rome and given the news? So I believe that we need to find so basically all of that is to come to this conclusion. I think we need to find the fastest way to establish a permanent foothold in space. So if you're drowning in the ocean, you're not going to wait for a yacht. You're going to, you know, grab a rope from a helicopter in order to save your life. So I want to look at some of the fundamental obstacles to space colonization. Now, this is, you know, we can do exploratory missions and we can have bases in a whole bunch of different places, and all that is good. But I think we need to also consider the actual colonization of space, of expanding civilization. And I think there are basically two important things that we need, two important obstacles. One is a return trip, and the other one is a key resource. I think the return trip is actually very important. A viable colony must have a reasonable way for two-way travel between itself and the motherland. Especially when the colony is small, people are going to still want to return back to Earth. And to have economic viability, and we were talking about this morning, I believe you have to be able to transport some kind of resources back to Earth. And you have to find a place where there are some critical resources, and I believe that water and gravity are actually two very important resources, and I think we perhaps don't emphasize gravity quite as much, and we'll see what I mean by that. So how do we get from the present to our space future, and remembering that the goal is actually permanent space settlement or colonization? So let's look at cities on Mars. Now, Mars obviously has great advantages. They've talked about that today, and someday we'll probably have cities like this on Mars, or even after terraforming, open cities. It has all the material resources necessary to support a large human population: water, carbon dioxide, all the metal ores, and it has a 24-hour day. But I believe that there's a significant obstacle that has two parts that is actually a significant obstacle for making it the first goal of colonization. Now, that doesn't mean that we can't send people to Mars to do scientific exploration. And that is gravity. It's both too much and too little. It's too much in the sense that it creates a really high cost for a return trip. Mars lies at the bottom of a significant gravity well, and getting back takes a lot of energy. The converse is also true. Gravity might be too weak to keep people acclimatized to Earth gravity, and if they spend, 1, 2, 3, maybe a decade of years there, they might not be able to adapt back on Earth. When we're young, we think we're invincible. When you get older and your back starts hurting, that's a significant obstacle. I used to do gardening, and I have a harder time doing gardening there. So when you come back to Earth and you want to start doing gardening, and you've been on Mars for 10 years, and now your back is out of shape, you can't do that. You might have some problems there. So, and in fact, I believe that what's going to happen if we're, eventually we make it to Mars and have a civilization there, is that we're going to actually see some changes in the genetics of the people, and we're probably going to have humans that we would consider, to be giants, like, let's say 7, 8 feet tall, and they might not even tolerate Earth gravity. So Mars might be the ultimate destination, but these obstacles, I think, make Mars a difficult first choice. How about colonies on Earth? The advantage is that these are the most accessible part of space, and people already live there, and normal gravity can be stimulated by spinning. The problem is, and this is the problem I think that the International Space Station has, is that there's basically no physical resources. We really don't want to go to space. We want to go to the bodies that are in space. There's a lot of energy there in orbit, but we still need physical structures to collect it. How about the lunar colonies? Again, short trip, and there seems to be a small quantity of water ice in the polar regions, and again, because of those advantages, we should probably have a base there, or perhaps do some exploration. But it has some significant advantages. It's dry. There is possibly some water, and it seems like a fair amount of water. It's like basically 30 feet deep lake that is 4 miles by 4 miles, and that's significant. But that's not enough to establish a really significant civilization. And it's scattered across a large number of cold-shaded craters, and so it'll be significant extraction costs. Now, if we find that there's actually a lot of water, well, that would probably change things. It's airless, so even if we have water, we don't have nitrogen, and that makes that complicates having the kind of atmosphere that we need. We also have to land using rocket power, and that makes it more expensive. Gravity is, again, similar problems to Mars, too low to maintain health, but high enough to add significant return costs. And then there's another big problem on the moon, and that is that you have 14 days of darkness. So that makes it very difficult to use solar energy, because you have to store solar energy for 14 days. Already on Earth, just the fact that you have to store solar energy for one night doubles the cost of solar systems. So if you have to store for 14 days, that makes it really difficult to use solar energy. How about the asteroids? I think someday most of humanity is probably going to live in the asteroid belt, hundreds of years from now, because there's incredible amounts of resources. But they're too far from Earth, the trip is too long, too far from the sun, we can't use naked solar cells, and the ones that are close are too small to be significant. So here we reach what I think is the catalyst, and it's a catalyst for the other destinations. They have similarities to the moon, Mars, the asteroids, orbital colonies. It's kind of the best of both worlds, and the gateway to the others. It's accessible. It's among the most accessible bodies in the solar system, even more accessible when it comes to cost than the moon. The return trip is cheaper than even from the moon because of the low gravity. It's close to Mars, so it could be used as a telepresence station for Mars exploration and development. It has microgravity, means that the moons could be mined all the way to the center, so that could be a practice for mining asteroids. Because of the microgravity, you could put rotating colonies below the surface that could produce normal gravity. So in a way, it's basically like having an orbital colony, but now you're close to all this huge amount of resources. That space station that we saw before, the Kalpana, would be about this size here in this crater. You can see that this little speck. You could put a whole bunch of those, and we'll look at that in a second. Fill this up with habitats like that. Now, here's the key, basically. The question is there water? These moons have a very low density, and it means that they either have water, and if they capture asteroids or comets, they probably do on the inside, or else they're 30% hollow. But how could it be 30% hollow? There is evidence of quakes, so even if there were all these caves and all that on the inside, and it's been smashed by meteorites, so if it was really hollow, you'd think that would have collapsed on itself. So there's probably a significant amount of water. If it is actually 1/3 of it is water, that is about 1/3 the size of Lake Michigan. That's 3,000 times the amount of water that's on the moon. That is a really significant and important resource. The dark color, this is enhanced. It's not anywhere near this. It's about the color of tar. And that means that it's probably similar to the carbonaceous chondrite meteorites. That means they have carbon, nitrogen, and sulfur. All the things that you need for life, for greenhouses, for atmosphere. Now, what is a disadvantage? How come people aren't talking about that? Well, I think that most people think that they're too small to be significant or interesting, and that's probably why they're being overlooked. Phobos measures 27 by 22 by 18 kilometers. Here's Deimos, which is even smaller. It's about the size of an average Virgin Island. So the question is it so small that it's really not worth establishing colonies there, and is it really just a detraction from Mars? The thing is, though, that if we think in 3D, we get a whole different picture. Because of microgravity, we can build spinning habitats all the way through to the center of the moon, and we can mine it all the way through because of this low gravity. So the volume, if you look at it from a volume and not from a surface point of view, Phobos has a volume that's close to 6,000 square kilometer or cubic kilometers. If you have a family of 4 that took up a space equivalent to a half acre of surface and 40 feet high, which is like the size of a 10-story building, you could put 1 billion people inside of, not Deimos, but inside of Phobos. Now, we probably wouldn't get to that kind of density because we have energy as a limiting factor, but if you covered Phobos with solar cells, it could produce 44 million kilowatts of constant electricity, except for occasional 1-hour eclipses. And if a typical person in New York uses about 50 kilowatts of energy, and that is including that 40 of these are basically sunlight for food production. So if you look at that, you could basically still sustain a population of 1 million. So, and that's way larger than, what we would have in the foreseeable future. So even if we establish a city, of 100,000 or 10,000, it seems like a worthy space goal. A worthy first goal, I'm sorry. And it seems like it can be done the most cheaply and quickly. Establishing such a colony can be done on the moons of Mars. Okay, so because of that, I think that should be the first place that we try to colonize, but only if there is water. So we need to find out if there is water. I think that we need to send probes to Phobos and Deimos to find out, and we need to do it soon. Now, some of the challenges and some of the goals: you have to get to Mars orbit, you got to do aerobraking, you have to land and operate on microgravity bodies, which we don't have too much experience doing that. But I think the experimental goals could be fairly simple. We could just send back pictures of the regolith. We could try to determine the composition of the regolith, have a robotic arm, pick out some samples. We could have an NMR spectroscoper to analyze organic compounds. If there are some there, we could do some kind of X-ray spectrometry to detect different metals. Being an asteroid, it might be littered with platinum on the surface, or it could have some of these rare earth metals. We don't know what's there. Maybe it's just a pile of dust and all we find is silicon oxide, but maybe it's littered with really valuable materials. We could try to detect volatiles on the surface, like a microatmosphere, basically degassing to see if there is actually water vapor, water on the inside. Use laser spectrometer for that. We could listen to sounds from the interior. Some people believe that there are these tidal movements, and that could probably shed some light on what's on the inside, whether there's a difference in the composition of the surface, and then have a lot more water on the inside. We could also have seismometer to detect these vibrations. We could use a ground-penetrating radar to explore the internal structure. And even that would give us some clues as to the composition, and we could try to drill below the surface or use some kind of a missile to harpoon the surface. And if need be, we could have a sample return mission, but really, I don't really think that's even necessary. I think that if we do this, that would meet the goals. When it comes to the price, there was an attempt to actually go to Phobos. The Russians had a sample return mission. The price was $64 million. They calculated that it would, the rest of the project would cost $100 million, including the stay on Phobos and the return back. And it launched in November 2011, but it failed to leave low Earth orbit. There was another one that also suffered catastrophic loss on the way. But this was a sample return mission, and it did a whole bunch of stuff on the way. So I think that simply landing putting a lander on Phobos and Deimos should be a lot cheaper about the cost of an orbiter. The Mars Indian orbiter costs about $73 million. So it could possibly be done for that price. Now, we could wait for the government to do it, and it's possible that Japan might send a probe to Phobos. But I think we need to start finding a way to get to privately finance some of this exploration. 73 million, if you did it over 10 years, would be $7.3 million. That's 300,000 people giving $20 a year. Wikipedia, which is also financed on donations, spent $58 million in 2015, so that's probably about how much they collected. So that is, that's pretty close to what we need in just 1 year. So a good campaign could collect, perhaps try to collect that amount of money. But I believe that if we really want to colonize space and we really wanted to go into space, there needs to be a motivator. We need to offer people that are donating this money something in return. And I think that one of the biggest obstacles that we have is this Outer Space Treaty. The Outer Space Treaty prevents the ownership of land and space. And when the government owns land and space, that's communism. So basically we have communism in space, and history has shown us that simply does not work. People have this very strong desire to try to own things and to be rewarded for the fruits of their labor. I talked to somebody one time that had come from the Soviet Union. It was a doctor that had emigrated while the Soviet Union was still around. They said, in the Soviet Union, they say, people say, we pretend to work, the government pretends to pay us. So is that the system that we want in order to get into space? When it comes to that, back in the year 2001, when I was younger and more foolish, I started this website called the Martian Federation, and I presented the idea of trying to fund the colonization of Mars by selling land on Mars. Even I didn't get any sale, but I did get a lot of traffic. I was surprised. I got traffic from all over the world. We had a forum, and people would write in, and we had lots of young people that volunteered to go. And I had some people even translate the whole website into Polish and into German from those countries. I had a long running dialogue with this fellow from Poland. And then later I kind of changed the business model. It seemed like interest sort of died. And perhaps it's because there's just a lack of interest in space colonization, but I think the change had to do more with the business model. I think that people would actually be willing to buy land on Mars and the Moon and the asteroids if the title was reasonably secure, and to buy resources. Remember as a child that my dad spent some money buying options on these gas claims up in Wyoming or Montana or something. People are willing to spend money if there's even a reasonable possibility that there will be some kind of payback. So we have to somehow get around the limitation of the Outer Space Treaty and find a way to make and guarantee reasonable claims to space resources. And that's something that I think we really need to think about. So here's just an idea. The probe could perhaps carry a plaque that says that the plaque belongs to the people that are funding it. Declare a 10-mile non-interference zone around the vehicle. That's basically symbolic. But I think what could be done too is if this were actually funded in that way, is that it could promise that if the moons of Mars are found to contain water, that further efforts will be made to send a permanent manned mission to colonize them, that those that donate would actually receive a portion of the profits. After all, once you have people in space, that would basically, they would be their own government. They could recognize property rights in space. One thing to keep in mind, both in this example, but also more generally, the first group, the First Nation, that sets up permanent settlement in space, at that point will basically own the solar system, and they will get a chance to set the rules. That doesn't mean that they're going to own everything forever, but they're going to get a chance to set the rules. That's what happened when the Spanish made it first to America. They got the chance to set the rules. Now, some of the rules that they set weren't the best ones, so they left space open for competition, and other countries came in. But if you're going to set good rules, once you have people up there, then maybe some of these problems, some of these limitations of space treaty would be gone. So in conclusion, we need to fund a Phobos Deimos lander. We somehow need to explore those two moons. They have not been explored. I believe that there is urgency to space colonization. We cannot wait for several generations. When I started that website, this is what my kids look like. Time is precious. This is what they look like now. So generations are coming and going. What kind of future are our children, our grandchildren going to have? And it's for them that I believe that we're doing this. I've given up hope on ever going to Mars. I tell my kids, when I die, I want you to have a regular funeral, but 5 years later, I want you to exhume me, burn me, and then keep my ashes. And someday, when somebody goes off to Mars, I want to be finally buried on Mars. At some point. I've told my children that, and I'm going to leave a little bit of money. Hopefully I'll make it to Mars one way or the other. But, I'm not doing this so much for me. I'm doing this for my children, my grandchildren. I believe that Phobos and Deimos are the best sites to set up the first permanent self-sustained space settlement, but only if they contain water. So we need to build and send a Phobos Deimos lander to search for water. And we need to come up with a model which guarantees ownership of space resources in a way that is legal and equitable. We need to get private funding for these projects, and we need, and then, for this project, I'd like ideas and volunteers. You can contact me on this website. There's a contact page. Well, thank you, and I'm willing to take any questions if there are any. Over there? Thank you.
What would your opinion be on a legal system or legal law, something like the Homestead Act of 1868 or the Mining Act of 1872, where if you go out and you homestead or if you file a claim, you get to keep it?
Yes, I believe that we need to come up with something like the Homestead Act, and I think that should probably be done by basically different countries making these treaties, United States with some of the other spacefaring nations, and kind of offer this to, basically everybody. There's some sites on the internet actually that sell land on Mars, but, they basically register it and then put in a book in the Library of Congress. Russia's not going to accept that, so we need to have something that is international. Question?
And then you do the GoFundMe, you go, this is our aim. We're going to make a small claim on Phobos. And the aim is, if you want to join us, we'll link up our colonies in our space. We want to GoFundMe a small probe to find water. And then you do that with the idea that you're not going, but I want to make a space for maybe my kids. And you list your kids as they are right now. And you contingent on their kids' too. If their kids' want to, they can go to Phobos first.
Right.
So you just keep snowballing it. And if you can't go, you pay a small fee, you have your little ashes go. So you just...
Right. I hadn't thought of the idea of that part, of actually sending your ashes over there. That might actually be a good idea, a good motivator.
Yeah, keep the generations all linked and all looking forward. That if I can't go, maybe my kid can go.
Right.
And my kid doesn't want to go, you sell that option to some other person that does.
Right.
You were the early pioneer, so you got in first on the ground floor.
Right. Well.
You worked with another group like Planetary Society.
Right. Well, that's a great idea, and I appreciate that. That's why I like to present, in these places. I'm just kind of starting out, and I appreciate the feedback. A question?
2 points. I've heard recently that apparently that there are high-level studies going on for a joint Japanese-French Phobos sample return mission that might launch, I think, around 2024. So there were news reports on it. You should check and see what the studies have been done, what they're looking at.
Right. I believe they're negotiating, and obviously, if they do it, then basically that question might be solved. Then it's just a matter of going to the next step and maybe promoting actually a colony there. But from what I could tell, I did a quick survey when I found out that was going on, and it seems that they're in the negotiating stage. So there's some preliminary talks.
It's pre-decisional.
Right. Exactly. So we have to see how that works. But in the meantime, I think even if we just promote the idea and let the government do it, that's another way to accomplish it. The problem is promote the idea and then nobody does it.
The second thing is that the impact ejecta on Phobos will generally be shock melted, much of it, form a temporary dust ring at the moon's orbit, and then gets reaccreted by the moon. The bulk of the regolith, like the lunar regolith, is probably shock melted glass and agglutinates containing small mineral fragments. If you look at the color-enhanced Phobos image at high local elevations, you see relatively blue and relatively red material, again in the enhanced image. It gets exposed